Installation issues. In this nugget, we're going to continue our discussion of partitioning by looking at two utilities, DiskDruid and FDisk. We're going to walk through how to use each one. After that, we're going to discuss dual boot installations and what you need to do to have a computer that boots two operating systems. So let's get to work. We're going to start a discussion of installation issues in this nugget by talking about DiskDruid and FDisk, which are two utilities that we use to partition disks. We'll compare and contrast the two, and we'll talk about how to use each one step by step. And once we're done that, at the end of the nugget, we're going to talk about dual boot installations. Okay, and I'm going to walk you through the process here of how to set up your computer so that it can boot Linux and Windows off of it. Okay, so for DiskDruid and FDisk, since they're both partitioning programs, you might ask yourself, well, when would I ever use one versus the other? Well, DiskDruid is only available to you when you're installing Linux. Okay, if you need to do some partitioning after you've already installed Linux, then FDisk is your only choice. So you might ask yourself, well, why wouldn't I just always use FDisk if it's available at installation and after installation too? Well, DiskDruid, most people find it to be more user-friendly. Okay, so that's why a lot of people use DiskDruid when they're installing Linux, but then they learn FDisk for, those times when they need to do some partitioning after installation. Now, another bonus for FDisk is that there's a variant of FDisk out there called SFDisk. We're not going to talk about this, I just wanted to let you know it was out there. It just allows the actions of FDisk to be scripted. Okay, so if you find yourself just partitioning disk after disk after disk after disk for some large installation, maybe you're putting new disks in, all the computers at your company or something, well then SFDisk might be a good choice, something to look into, because then you can write a shell script that will do all that partitioning for you, so you don't have to go from, and type command after command after command to get all those disks partitioned. Okay, so what we're going to do now is move on and talk about how to use DiskDruid. So if you're doing a Linux text-based installation, this is what the disk partitioning setup screen looks like. Okay, if you're doing a graphical installation of Linux, functionally it's the same, but it just might look a little bit different, so I just didn't want to throw you off there. But I'm sure you'll be able to follow along just fine. So there's an auto partition selection, which we used in the introductory videos, which is fine for just a basic installation. But if you need to control how the disk is partitioned, you're going to need to use DiskDruid or FDisk. So I'm just going to, these are a bunch of screen captures here, so I'm just going to move forward through the screen captures. Remember, you tab to move between elements and you use spacebar to select elements during installation when you're doing a text-based installation. So I tab over to DiskDruid, I hit spacebar to select it, and it brings up this warning screen that says if you're going to create a new partition on this disk, the disk must be initialized or formatted, and you're going to lose all the data on this drive. Yes, we want to do that, we're sure of that. And now it brings us to this partitioning sort of status screen. So it tells us for all of our disks, which I only have one disk, so only one disk is listed here, how much free space and what partitions you have on that disk. Well, since I haven't made any partitions yet, there's no partitions listed, and it's just all free space. And there's 4,094 megabytes or 4 gigabytes of free space. So now, as long as there's free space in this list, and I hit new, it's going to prompt me for the information for the new partition. So I'm going to select new, and now it brings up this add partition screen. Now, to add a new partition, you have to fill in all these fields. The first field you have to fill in is the mount point. So what directory are you going to mount in this partition? Like /boot or /user or /home or just / if you're going to mount the whole directory tree in this partition. Over here is a list of file system types, x2, x3. This list actually goes down farther, like swap and vfat. We'll see that later. Okay, but for right now, we're there's our list. Here's the drives that we have available to us. Again, because I only have one drive, only one thing's in this list. And then once you pick the mount point and the file system type and what drive it is, then you have to say how big the partition's going to be. And you have three choices or three ways you can specify the size of the partition. You can either just write in a number here like 500 and say, okay, I want a partition that's 500 megabytes big and it's a fixed size if that's checked. Okay. Another way you can do it is you can check this box and say fill to a maximum size of this many megabytes. So if I filled 500 in here, it would fill up to but not over 500 megabytes. So if there wasn't 500 megabytes left on the disk or it had to do some rounding, then the maximum size will not go over 500 megabytes. Or I can check fill all available space. So all the available free space that's out there, if I check this box, will go into this partition. You can force it to be a primary partition as opposed to a logical or an extended partition, and you can check for bad blocks as well by checking this. So let me jump forward in the screen captures here, and you can see how I filled all this in. So my first partition, I've made a /boot partition. I've made an X3 file system type on the first disk, and I've made it 100 megabytes big, fixed size. I forced it to be a primary partition, I forced it to check for bad blocks, and now I say OK. All right. Well, now I've got this partition SDA1. It's an X3 file system type /boot's the mount point, and it made it 101 megabytes big. Okay, so it's always going to round up here if you don't tell it otherwise. If you specify 100 and you say make it a fixed size of 100, it's going to round up to the next number that sort of makes it all work out for the system. Okay, there's a lower level disk geometry here that we're not talking about, and we don't even want to think about that. So we just specify 100 and it makes it 101. Who cares? 1 megabyte out of a 4 gigabyte disk isn't such a big deal. Okay, now you can see here there's free space and there's 3,992 megabytes of free space. So I'm going to create another new partition. I'm going to select new, and now I've got this one. I've already filled this one in for you. So again, here's a new partition I'm adding. This one I'm making my swap partition. So I've scrolled down this list to swap. As soon as I pick swap, it makes the mount point, it says not applicable, because swap partitions don't have a mount point. Users, even system administrators, can't write directly to the swap partition. Only the operating system uses the swap partition when it's trading stuff in and out of main memory. Okay, I've made it 500 megabytes big as a fixed size, and I said check for bad blocks. Okay, so how big should you make a swap partition? Most people will tell you about twice your main memory size. Okay, so I've got 256 megabytes of main memory, so I have 500 megabytes of swap space. Okay, so let's jump forward here. I'm adding another partition. Okay, so what I really had to do in here was go back to that status screen, hit new, and now I'm back here again. Here's how I filled out this partition. I said the mount point is /, which is the rest of the directory tree. It's again an X3 file system type on the first disk. Notice I didn't pick a size here. I just said fill all available space. I only want 3 partitions on this disk, okay? And so I said fill all available space because I don't want space left over. If I guessed here and said, oh, it was something like 3,400 megabytes, I don't remember exactly, but if I said 3,400 there and picked fixed size, then there would be some number of megabytes left over that would be unused on my disk, and that just seems silly, right, to have unused space on the disk that no file system or no partition is going to have access to. So you just say fill all available space. Again, I say check for bad blocks, and I select OK, and now it brings me back to the status screen once again. Okay, so here's the summary, right? 1, 2, 3 partitions. The first partition is that /boot partition, 100 megabytes big. Second partition is the swap partition, no mount point. Okay, the third partition is /, which is the rest of the directory tree, and it made it 3,490 megabytes big. Okay, so that's how you use DiskDruid to partition your disk. As long as there's free space in this list, you can keep adding new. Okay, once the free space has run out, like it has now, you can't click new partition. But you can go back and edit things. You can go back and reselect stuff. So if you get to this point and you realize, oh shoot, I forgot this other partition, I wanted to do this, or I wanted to set it up this way, you can always go back and change it before you actually get to the installation. Now let's move on and talk about how we would use fdisk at installation time and also post-installation time. So let's just see what it looks like to run fdisk from the installation program. Okay, so if I select fdisk, the first thing it asks is what disk do you want to run this on. I select SDA, and now I move forward and I'm at this add partition screen. Well, does this look familiar to you? It should. It's the exact same screen that we saw for DiskDruid. So the information that you put into fdisk here in this screen is exactly the same as DiskDruid. The underlying program that does the partitioning is different, but we don't care about that. We just want to know how to input this information. And so running DiskDruid or fdisk at install time is practically the same thing from a user's perspective. And now what I want to do is show you how to run fdisk from the command line so that you can actually run the program once Linux is already installed. All right, well, let's run fdisk from the command line. And the way that I'll do that is I first have to become the super user, because you have to be the root user to run fdisk. And then you type fdisk followed by the device that you want to run it on. Okay, so I only have one disk in my system. It's a SCSI disk, so it's /dev/SDA is the way I specify it. Okay, fdisk is in the /sbin directory, which is already in my path. If it's not in your path, you'll have to type /sbin/fdisk to run the command. Okay, so I'll hit enter here, and the first thing it says is command M for help. I like to think of it as M for menu. So it's a menu of all the different commands that you can run. All right, and each letter here corresponds to a command, and if you type that letter down here and hit enter, you will invoke the command as it's listed there in English. Okay, so two things to note before you do anything. Okay, one is that fdisk can absolutely, positively, completely screw up your system. Okay, that's not why I'm teaching it to you. Okay, so you can go in there and completely destroy your system. But that being said, don't let that stop you from poking around and learning stuff, because there is a command Q so that you can quit without saving your changes. So go ahead in there and delete partitions, add new partitions, mess around with stuff, but make sure you hit Q to quit without saving changes, so that you don't actually alter anything about your disk. Okay, whatever you do in fdisk, none of that gets your disk doesn't actually change until you hit W, which is write the partition table to disk and exit. Okay, so if you're doing serious work, if you're actually doing something meaningful, then make sure you use W at the end to write your changes. But if you're just messing around, or if you're going along doing something serious but you think you messed up, just hit Q and you'll get to start over, and no actions will be taken. Okay, so the first thing I want to do here is just print the partition table. I want to hit P, and this is the current partition table of my disk. All right, and it lists a whole bunch of stuff here, the number of heads, sectors, cylinders of my disk. This has to do with the underlying geometry of the disk. We're not going to talk about that. There's plenty of resources out there if you're curious about what all this stuff actually means. But then down here under the device heading is the 3 partitions that I have on my system, SDA1, 2, and 3. You can see here that SDA1 is the bootable partition, and in there, that's where my /boot directory is mounted to SDA1. Okay, it tells you where the starting and ending cylinders are, so it's 13 cylinders big. Okay, it's 104,000 blocks big. So the information's here about how big this partition is, but it's not necessarily very intuitive, right? Like in the DiskDruid screens that we saw at installation time, it was telling us that something was 101 megabytes big. Okay, and here it's not saying that. Okay, it's just saying, oh, it's 104,000 blocks big. Okay, its ID is 83. The system is Linux. It's not telling us that the /boot directory is mounted to this partition. So this is just a real bare bones rudimentary display of the partition table. Okay, this is just the basic information that the system needs to know about the partitions. Okay, so here's what I want to do is I just want to mess around and do some damage here, but I'm going to hit Q before I end. I just want to show you how to do stuff like add partitions and delete partitions with fdisk. Okay, and another note is that this is not the typical way that you're going to use fdisk. Okay, you're not going to have like a fully functioning system with user accounts and people logging into your system, and then you're just not going to go in there and start deleting and adding partitions if you have this fully functioning system. You're just going to completely mess stuff up. Okay, the way you're going to use fdisk in practice, the most common way is just say you add a brand new hard disk to your system. So you've got a fully functioning Linux system. You add the brand new hard disk to your system, and you've got to partition that disk up and format it and so on before you can put data on it. Okay, and the way you're going to partition that disk is with the fdisk command, very similarly to how I'm going to do it here, even though I'm just playing here. Okay, so the first thing I'm going to do is delete a partition with the D command. It says, what partition do you want to delete? I'm going to delete partition 2. Okay, and now I'm going to print the partition table again with the P command. Okay, now you can see that from cylinder 14 to 457 is all gone. All I have listed down here is partition 1 and partition 3, and partition 2 is just gone. Okay, well, let me create a new partition. I'm going to do that with the N command. It says, do you want an extended partition or a primary partition? Well, I'm going to do a primary partition, so I'll hit P and hit enter. And it says, what number do you want to use? I'm going to use number 2. Now it says, what's the first cylinder that you want to use for this partition? Okay, it says the default is 14. The reason the default's 14 is because partition 1 ends at 13, so they're just assuming that you want to start at 14. So I can either type 14 or just hit enter. And if I hit enter, it says using the default value 14. Okay, so now we've said that we want this new partition, number 2, that I'm creating, to start at cylinder 14. Now it says, how big do you want it to be, basically. It's saying specify the last cylinder. So if you're familiar with how many cylinders correspond to how many megabytes and so on, you can do that calculation. Or you can just do this one, which I think is the most useful one, plus size m. You can specify the size in megabytes. Okay, so you can specify a cylinder number or the size, and I think the most common way to specify a size is in megabytes as opposed to, specifying a size in bytes or kilobytes. Okay, so I'm just going to do this. I'm going to say plus 500m. Okay, so plus size m, plus 500m gives me a 500 megabyte partition starting at cylinder 14. I don't know where that's going to end. I don't know in the top of my head how many cylinders 500 megabytes is going to occupy. And this will do the same thing that DiskDruid does. It will round up to make it, an even number of cylinders or a round number of cylinders. So it's not like, 17 and a half cylinders or something. It's going to make it a whole number of cylinders, and it might end up being 510 megabytes or something. Okay, so I'm going to hit enter here. And now I created the partition. Let's hit P to print the partition table again to see my new partition. So there's dev SDA2. It runs from cylinder 14 to cylinder 77. It's 514,000 blocks big, which is around 500 megabytes. Okay, and it's a Linux system. It's not a swap file system. It's just a Linux file system. But it does not actually have a file system yet. It doesn't have a mount point either, and we're going to talk about how to give it each of those values, how to associate each of those values with this partition in a minute there. I just wanted to show you this is how you create a partition. Now I could create another partition here, again, typing N. I could put partition 4 and run it from 78 to 457. And it doesn't matter that they're out of order. Like, partition 2 runs from 14 to 77, partition 3 runs from 458 to 522, and partition 4 can run from 78 to 457. That's perfectly fine. Okay, so that's the idea of how you create and delete partitions. Now, like I said, let's talk about how to associate mount points and create file systems on the partitions. Before I forget, I'm going to hit Q here to quit, and then I'm going to walk you through how to do that next step. So now we've created this partition, supposedly at least. We didn't actually do it there. But say we created this partition, and now you want to put a file system on there. In other words, you want to format that partition so that it can handle data now. Well, one of the ways you can do that is with the mke2fs command. Okay, now that's a real hodgepodge of characters, so let's dissect that. mk stands for make, e2 stands for the ext2fs file system. So this says make an ext2 file system, like on dev/sda2, something like that. So that would format that second partition on the first SCSI disk, and it would put an ext2 file system on there. Okay. Now you might be saying to yourself, well, I thought we were putting ext3 file systems on there before, and you're right. That's what was on there when we were doing DiskDruid at the installation time. We were putting on ext3 file systems. Now the difference, let me just give you a quick little summary here. The difference between ext2 file systems and ext3 file systems is that an ext3 file system is a journaling file system. These are like the newfangled file systems that are out there. And the journaling just means that it keeps track of all the writes that happen to the file system. So every transaction to the file system in an ext3 file system actually takes a teeny bit longer because it journals it, because it keeps track of what happened to the file system, any changes that took place. And you might be saying, well, that seems slower, right? Every transaction takes a little bit longer. But because it's journaled, big things that you do to the file system, like a file system check, happen much faster. Okay, so it's kind of a trade-off. If you're not doing file system checks very often, or if you're in some really high performance application, then maybe an ext2 file system would pay off. Okay, but in typical everyday use, ext3 file systems seem to be better because they have journaling in them. Now you're saying, well, how do I create one of these ext3 file systems on there? Well, what you would do here is you would actually use the same command with the -j option, which says just add journaling to this file system that I'm creating, and that would create an ext3 file system on this particular device. Okay, so that's how we make the file system and put it on the particular device or the partition that we just created. Okay, since we didn't actually create that partition, I'm not going to run that command because I don't want to format the partition that's already out there. That's for real. Okay, so that's how you make a file system. Now let's talk about how you associate mount points to that file system. We talked about how to mount directories and how to get directories to auto-mount back in the introductory videos. I just want to give you a little reminder in case you forget. One of the things that you have to look at is the etc fstab file. Fstab stands for File System Table. Okay, so this lists the things that are auto-mounted or not auto-mounted. It lists what directories are mounted, what kind of file systems are out there. And if you need a refresher what each of these columns means in this list, you can look at the man page for fstab. And if we do that, you'll see that if I page down here, like the first field is this, and I'll page down with the space bar. The second field describes the mount point. The third field describes the type of file system, and so on. Okay, just quit out of here with a Q. And that'll tell you, the man page will tell you what each of these various fields means. So once we've created the partition and associated a file system with that partition or formatted that partition, then you need to mount the partition as the final step before you can actually put data on it. Okay, so there's a little quick refresher of how you get a mount point associated with that partition once you've already created it. And now we're going to move on and talk about dual boot systems. Alright, so we want to talk about dual boot systems here, and the goal is to have Linux and Windows installed in the same computer, and then when you turn the computer on, you get to choose which one you boot up. Alright, so I'm going to assume one of two cases. Either nothing is installed on your system yet, and then we'll install Windows and Linux, and I'll show you how to do that. Or Windows is already installed and we want to add Linux to that system. So if nothing is installed on your system yet, then the first thing that you should do is install Windows. And I'm assuming you're going to install NT or 2000 or XP. And in any of these, you get to choose how you partition the disk and make sure you leave enough free space for Linux. How much free space do you need for Linux? Well, we talked about that in the last video. Now, if you want to be able to read those Windows files from your Linux system, make sure you use the VFAT file system and not NTFS. VFAT is Linux compatible, NTFS is not Linux compatible. So now once you've installed Windows and you've left enough free space for Linux, you install Linux in that free space. And here's another thing to note, and this probably doesn't apply, I haven't run into this for ages, but it's still something to mention, is that some older BIOS have a 1024 cylinder limit. So what this means is that the /boot directory for Linux must reside in the first 1024 cylinders of the disk. Remember when we were talking about DiskDruid and fdisk in the installation screen, there was a cylinder starting and ending point for each partition. Okay, so the /boot partition must reside in that first 1024 cylinders. Okay, so that's if nothing is installed. That's not so bad. You install Windows, then you install Linux in the free space. Now, if you already have Windows installed, it's a different case. The first option, if you already have Windows installed, is to just add a new hard drive for Linux. Okay, so if you've got a hard drive out here, it's already got Windows on it, there's space being used all over the hard drive for various things, well, probably the easiest option and the safest option is to just add a new hard drive and then install Linux on that hard drive. Okay, so that's one option. The other option is if you have an existing hard drive or partition already on your Windows system and you can rearrange things, well then you can install Linux on that extra hard drive or extra partition. So like in your Windows system, say you've got a C colon and a D colon. Well, this could either mean that you have two physical drives, a C drive and a D drive, or you have two partitions on one hard disk. So what you can do is, before you do your Linux installation, if you think you have enough space in the partition for Linux, say the D partition, and you've got enough space in C to handle all the data from D to be copied over there, then you could try this. Okay, so you'd back up all the data from D, you'd put it over into C, and now D is empty, and you can install Linux into D. Okay. Now, when you go to you're doing the Linux installation and you get to that partition setup screen, then this is going to be notated in there either as SDA and SDB if they're two physical drives that you had, or like SDA1 and SDA2 if they were two partitions on the same hard drive. Okay, so whatever it is, you're just going to take SDB or SDA2 here and then install Linux on that particular partition or that particular disk. Okay, so like I said, this is probably the most desirable option, just to add a new hard drive. It's probably the least amount of work, but it costs some money. This is, in between here because it takes some work to recopy the data over and then install Linux on that one. And then if you have to create a new partition, if you don't have an existing extra hard drive or an existing partition, you have to create a new partition. This is probably the most amount of work. It's probably also the option that'll get you the least support from Red Hat and the least support from the community, because there's so many things that can go wrong here. Okay, but one thing that you need to know here is that there's a program out there called Parted that will help you create this new partition to install Linux in. Some old Red Hat documentation mentioned a program called FIPS to do this. Don't use FIPS. Use Parted. It comes on the Red Hat 9 installation CDs, and it's also just available out there on the internet for you to pick up. So if you need to do this option, you need to look into how to use this Parted program to do those partitions. So then once you get into the installation for Linux, you're going to get to that disk partitioning setup screen. Okay? Now, so you've got some free space out there, and you're going to partition that free space for Linux. Well, how do you partition that free space? Well, that's kind of what we've been talking about, this whole nugget, right? You can either use auto partition, but make sure if you use auto partition, you choose the option, keep all partitions and use the existing free space. Okay, if you were installing Linux and just trying to wipe out Windows, then you would just wipe out the whole disk and install Linux there. But you're trying to have them coexist, so you need to make sure you pick this option to keep all partitions. Okay, or you could do manual partitioning using Disk Druid or fdisk like we talked about earlier. And then it's up to you to make sure that you don't delete those Windows partitions. Okay, so you have to make sure you understand which those are, and they're probably the ones that are labeled with VFAT. That's nice. If you chose VFAT for your Windows file system, they'll be identifiable at this disk partitioning setup screen, so don't delete those. Okay, they're the ones you need to keep to make Windows run. All right, now the final steps are just that Red Hat will detect Windows, and it'll set up Grub and Lilo to boot either one. So when you get to that bootloader screen and you have to pick Grub or Lilo, well, you can pick either one. And then Red Hat will detect Windows and set it up so that either one can be booted. And the way that you choose is when you start up your computer, the bootloader screen will come up, and Linux will be in there as Red Hat Linux, and Windows, the operating system that you've installed, will be referred to as DOS. Even if it's Windows 2000, Windows XP, Windows NT, whatever it is, it'll be referred to as DOS. So you choose DOS to boot the Windows one, or you choose Linux to boot the Linux operating system. And that's it. All right, well, it's time to wrap up this nugget. This was our nugget on installation issues, and we're going to have more discussion of installation issues in the next nugget. But this nugget, we talked about Disk Druid as a partitioning tool. We walked through how to use Disk Druid. But remember that Disk Druid is only available when you're installing Linux. Then we talked about fdisk, which is available all the time. We went through how to use fdisk at the command line, and we played around. And remember, there's that Q option in there to quit without saving changes, which is a good way so that you can play around but not cause any damage. One thing that I didn't note before is that this is not the same as the program fdisk.exe that's available in DOS. So if you're used to this program in DOS, the interface is different, the underlying program is different, so just be aware that this is not the exact same fdisk. And then we wrapped up this nugget by talking about dual booting our computer and how to set up our computers so that we could boot both Windows and Linux. Well, I hope you found this nugget informative, and thanks for viewing.